Okay, this video is the continuation for chapter 1.1. So now I will cover on chapter 1.2, which is on part of control system. Okay, there is a few things that we will cover inside this video, which is elements in control system, basic terminologies in process control. These two actually have been covered inside the previous videos, but in here we will cover in details, and I will show you the photo of each of the devices for the elements in control system. Okay, next, symbols used in control system configurations, types of controller, analog and digital processing, and lastly I will show you a few case studies. Okay, as per introduction, okay, in a chemical process we have numerous input and numerous output. So this diagram shows that this process is a separation process. So in here we can see that in the separation process itself we have a few inputs. That input can be flow rate of component A, component B, component C, the feed, the water feed, the mixture feed. So there is a few inputs. All these input have chances to be manipulated input or disturbance inputs. So with this input, recall back from previous lecture, this input actually is a raw material. When they feed it into the process is used to turn the raw material into the output, which is our products. So this output normally is a mixture of all those input here. Okay, now I cover on elements control system. Okay, basically this block diagram, like what I'm show to you inside the previous video, this is the closed loop system. We have controller, we have final control element, and also we can say that as a valve or actuator. We have process, we have measurement element, normally sensor, and then we have set point. So basically this is the process. Okay, the output of the process here will become our control variable. So we have a sensor to measure whether that control variable CV value is equal to set point or not. So now if let's say like what I'm saying inside the previous video, if the CV is 100 degrees Celsius, so the measurement, the sensor will read and measure, and then for example it measure 90 degrees Celsius here, and then it will send the signal to the controller. So in here we have 90 degree Celsius reading, so the set point actually 100 degrees Celsius, so the error we can calculate 100 minus 90 become 10 degrees Celsius. So the controller will make a decision based on the error signal. So based on the error signal, the controller will send the decision and ask the final control element, for example like valve, to take an action whether to, if let's say if we use a valve as a final control element, it will ask the valve whether to increase, to open or to close, or to open 100% or to open 70%, close 20%. So depending on the decision based on the error calculation here. Okay, so normally the final control element, which is valve, is placed or located at the manipulated variable. For example, like we discussed on previous video, our manipulated variable is steam in red. So normally this valve will be located at the pipeline of the steam in, like this. Okay, so in order to cater the problem of CV didn't reach the set point, the controller will ask to open how many percent in order to cater the problem. Okay, I explain it back about process. What is process? The material equipment along with the physical and or chemical operation which take place. Normally process is a continuous operation that transform input to the output. So example of the process, like this one is reaction, this one is a heating process. Okay, measurement element. Measure the output signal, physical or chemical variable, and send the signal to the controller for corrective actions. So this is the figure, the photo of the real sensor. So this one, the example of the level sensor. So this level sensor is deep into the tank, and then it will detect the level of the tank. So this one is the type of controller. The controller is the device which evaluate error of the control variable and initiate corrective action to the final control element. So we have a few type of controller, which is analog or digital. So this controller is an example of a digital control system. Okay, moving to the next final control element. The function of the final control element is to manipulate the manipulated variable to affect the output under command of controller. So we have this is only a few example. We have a lot, many type of valve actually in the real plant. So this one is a manual valve. So this one can be operated by human. So this is a control valve. Normally it is connected to the controller, automatic control system. So this is our DC motor. So basic terminologies in process control. So first thing is the main important thing is set point. So set point is the input representing the desired value of system. Set point value is compared with the output to actuate the controller. So basically here is a one complete control system. So this is our processes. So this is our main processes. Normally this control system is only a small size as compared to the process. So okay, here set point is the input of our control system. So in here, the first thing we have to set our target, which is the control variable. For example, temperature, output temperature, TO, must be equal to 100 degree Celsius. So this is our CV. So normally the set point is actually what we targeted. So set point is equal to 100 degrees Celsius. Control variable here is our temperature output. Temperature output variable. So 100 degrees Celsius value, this one is a set point. Okay, so this set point will be compared with the measured value from the output here, and then it will send to the controller to make a decision. Next, our manipulated variable, quantity or condition which is varied by the controller to affect the value of control variable. So basically manipulated is the variable that we manipulate in order to cater the problem or to affect the value of control variable. On a typical chemical process, there are generally any control variable and manipulated variable. Okay, so like what I'm saying before, this one is a control system, complete control system. So basically the MV, the manipulated variable, normally is the feed of the process system. Okay, so this feed is actually been manipulated so that we can adjust or maintain this control variable. Okay, next is our disturbance. Disturbance, like what I'm saying inside the previous video, it is unwanted signal that tend to affect the output value. Internal, generate within the system. Disturbance can be internal, generate within the system, or external, generate outside the system. Okay, so this one is example of generate outside the system. So the disturbance is actually the input, the another input or the another variables that fit into the process. But this variable is one of the unwanted variable that can affect the value. For example, like we have a process of reaction here. So this one we feed the input, and this one maybe we feed the another input. So if we choose the first input as a manipulated variable, the other input it have high chances to be disturbance to our system. Okay. Disturbance also a variable that fluctuates and cause the process output to move from desired operating value. Can be a change in flow, temperature of the surrounding, pressure, and etc. It also can be further classified in terms of measured or unmeasured signal. What is measured and unmeasured signal? Measured signal is the one we can detect by the sensor. Unmeasured signal is the one that cannot be detected by the sensor. So next is control variable. Variable of quantity or condition which are measured and controlled. So normally the control variable is a system output. So this control variable we measure, and this one also we need to control. Why we measure? Because we want to compare it with set point so that the controller can make addition and ask final control element to take a decision if there is any changes occur to the control variable. So next is error, the difference value between the set point and output. and serve as input to the feedback control. Okay, basically, error is the one that I mentioned before. We have set point. Basically, the set point is set inside the controller. This controller is actually a digital computer. So we set at that computer, we want the temperature 100 degrees Celsius. So the process give the process output here, we measure process output, we measure, and then the value of the process output is sent to the controller, and then this system, this controller, the digitalized computer will calculate. There is a programming inside this one. They will calculate and come up with a decision. Okay, next moving to naming used in control system configuration. So for controller, we have temperature controller and the name is TC. So normally in PNID, we will see these symbols. So this symbol is for temperature controller. If you see FC with the round symbol, that was a flow controller. So level controller, LC, pressure controller PC, feed forward controller FFC, ratio controller FRC. So for transmitter, in the round shape we have the naming like T at the back. T at the back is transmitter. So the in front T is temperature. If FT flow, if LT level, PT pressure. Okay, now we move on to type of controller. Okay, we have two type of controller, which is analog controller and also digital controller. So for the analog controller, is used for continuously varying control signal. The example of analog controller is on-off controller, proportional controller, proportional plus integral controller, proportional plus derivative controller, proportional plus integral plus derivative controller. Okay, so for the on-off controller, okay, this is the example of the level control system. Okay, we can see here there is a flow in, feed into the tank. Okay, we have L1 and L2 as an indicator and P1 is a sensor. Okay, when the water level reach L1, this is like manual sensor, this P1 will be closed, and when it closed, it causes the power supply to turn on. So when the the level of the tank reaches L2, it causes the P1 to open. When the P1 open, the power supply is cut off. Then there is no flow. This valve also will be turned off, and there is no flow will be fed into the system. So this is the example of on-off. So when it reach the below limits, it will turn on. When it reach the higher limit, it will turn off. Okay, for the example for the item 2, 3, 4 and 5, P, PI, PD, PID controller, it's like this one. It's actually inside that control system, inside the controller itself. Just now, we can choose whether you want to use P, PI or PID. So it's depend on the value that we key in inside the controller itself. So for the P, we have this kind of equation, I this kind of equation, D this kind of equation. Okay, next is digital or discrete controller. So use digital concept to control the system. So example of this digital controller is programmable logic controller, which is PLC. So basically, the input here is the sensor, the signal, sensor signal. The sensor signal will be sent to the input of this PLC system, and then the input will be sent to the CPU, and it will be programmed inside the device, and we will do a changes, or we can monitor from the device. And this programming device, this CPU will act as our controller, and make a decision and send the output signal. The output signal will be sent to our final element device, our final element device. For example, valve. Okay, analog and digital processing. So we have analog to continuous. Analog, normally the signal is continuous. Digital, normally we use computer, and it is in a discrete manner. So majority we use on-off controller. This is the example of the smart sensor that attached to the our digital system. Smart sensor is a device with a small housing contain complete set of measurement and control, including analog digital or digital analog converter. So this one, if we combine using the analog system and also digital system, so that we can convert from analog to digital or digital to analog. So for the data representation, for analog, we can see the signal, the graph, the response is continuous. Meanwhile, for digital, is in a discrete manner. So we have like 1, -1, 1, -1, for example, like that. So for analog, we have 1, 1.2, 1.3, 1.5. Okay. So the difference of analog signal and also digital signal, the advantages: analog signal is simple, inexpensive, do not require high accuracy and flexibility. For digital signal, can be very immune to noise. And also signal can be transmitted over long distance. The disadvantage for this analog signal is there is a huge noise. We have a random unwanted variation. For the digital signal, the disadvantage is output subject to quantity error from sampling. Okay, now we move to case study. So I plan to cover maybe 2 or 3 case study. Okay, we start with case study 1. Suppose that is desired to maintain temperature of the home at 72 degree Fahrenheit. This temperature is desired value or set point. So this one, 72 degree Fahrenheit is our set point. A thermostat is installed on an inside wall of the home and measure an existing room temperature. So thermostat is our sensor. This temperature is to be the control variable. So this temperature of the home is our control variable. A person watching the thermostat notes the temperature is 69 degree Fahrenheit and is therefore less than desired value. That means the control variable is deviate from the set point, which is 72 degree Fahrenheit. The actuating signal, the error, is 3 degree Fahrenheit. 72 minus 69. An action is then taken to reduce this difference by on the switch that turn on the fuel gas to the furnace burner. The flow of the fuel gas is the manipulated variable. As the furnace heat, warm air is delivered to the room. So warm air delivered to the room, and the temperature will presently increase. In a short time, the temperature become too high. If the temperature become too high, then the whole sequence must be repeated in the opposite direction. So that's mean the temperature of the home we want to set 72 degree, and then if the signal if the sensor detect the temperature 69 degrees Celsius, there is a person see the thermostat notes, and then he start to on the fuel gas, so that the fuel gas will feed into the furnace burner. Then the burner will start to warm up the room, and then the temperature of the room will start to increase. Okay, so now we want to know what is the control variable, manipulated variable, disturbance variable, set point, and also what is the component involved inside this process. So this is the block diagram for this process. Okay, just now we have the process is inside here on the switch that turn on the fuel gas to the furnace burner. So here. So our control variable just now is home temperature. Our set point is home temperature at 72 degree Fahrenheit. So our manipulated variable is a flow of the fuel gas, just now got mentioned, right? So our disturbance can be temperature of the fuel gas itself or the flow of the fuel gas. Okay, the process is in here on the switch that turn on the fuel gas to the furnace burner. So the controller here is a person, because that person is adjusting the thermostat, right? That person see the thermostat and adjust the switch on the fuel gas, right? Flow of the fuel gas. So the actuator here is a solenoid valve, and the sensor is our thermostat. Okay, I hope you can understand. But this one is an example of manual control. Now I move to the automatic control. Okay, so this is the stir tank. So it's stir tank figure. So the temperature of the stream leaving the stir tank is the control variable. So temperature here, temperature leaving is a control variable. Many other output variables exist, such as the output flow rate and the exit heating oil and heating oil temperature. So we have a few other output variables instead of the temperature of the stream. Flow rate also, exit heating oil here. A manipulated variable is selected for adjustment in a control strategy to achieve the desired performance in control variable. The heating oil pipe is the manipulated variable. So here, heating oil pipe is the manipulated variable. Since by opening the valve increase the flow of heating oil, and result is greater heat transfer to the fluid in the tank. A feedback control system is needed to achieve the desired behavior of the output variable. The output is measured using thermometer. So thermometer is our sensor, right? Okay. So we want to identify the four components of the control system in the above process, which is measure, decision, action, and self process. Draw its functional block diagram. Identify the following control variable, manipulated variable, set point, and also disturbance. Okay, now we move to solutions. So the process is in here. Maintain temperature of the stream leaving the stir tank. So okay, the output here is the temperature, the fluid leaving the temperature of the stream leaving the stir tank. So our output is our control variable. So temperature of the stream, output stream. Okay, now we have a sensor to measure the control variable. So the sensor would be thermometer, and then the signal is sent to the temperature controller. So the controller is this one is temperature controller. Okay, the temperature controller will make a decision and send the signal in the form of controller output CO to the valve. Valve is our actuator, which is our final element. Okay, so our manipulated variable would be the heating oil, right? The heating oil. The heating oil in the pipe. The heating oil. Okay. Now, what left is our set point. Our set point would be the desired temperature of this stream. Okay. So disturbance, it can be our output flow rate, our exit heating oil temperature. So like what I'm saying before, normally the variables is we have for example the tank just now, right? So we have input, we have output, and we have heating, input, output. So we have this is variable 1, which is temperature in, flow rate in, temperature out, flow out. So this one temperature in, this one temperature out, flow in, flow out. So this one is our manipulated variable. So the rest can be our disturbance variable. To identify accurately, actually you have to do a sensitivity test, but for your general knowledge here, you can pick what are the variable left here. It can be a output flow rate here, it can be the exit heating oil temperature here. Okay, finish for case study 2. Now we move to case study 3. So for the case study 3, we have water heater system. The purpose of the heater is to maintain a supply of heated water. The variable most indicative of this purpose is the temperature of the water at the outlet. So this one is our CV. This temperature is called the control variable, temperature of water outlet. The heat flow rate must be manipulated by controller. So here, the incoming water temperature is the load variable. So this one load also known as a disturbance. It is expected that automatic controller will correct the fluctuation in load variable and maintain the control variable at desired value. Okay, let's identify the 4 components, draw the functional block diagram, identify the following items. Okay, so we have water heater tank right here. We want to maintain a supply of heated water at desired temperature in a tank. Okay, this is our process, maintain a supply of heated water at desired temperature in tank. Okay, so the output of this system is the temperature of water at outlet, right? So this output is our CV, temperature of water at the outlet. Okay, we move to the measured sensor. So at sensor, just now got mentioned inside the figure, right? They use RTD, resistant temperature detector. So this is our sensor. So go back to the controller. Controller got mentioned also, we use the automatic controller. So automatic controller. Okay, the set point is the desired water temperature at outlet, and our manipulated variable got mentioned inside the statement just now, heat flow rate. So we have another variables left, which is fluid flow rate, heat flow rate, ambient temperature. So all of this can be our disturbance variable. And lastly, our final element actuator, which is water heater. So this water heater we manipulate the temperature of the water. Okay, so I think that's all from me for subchapter 1.2. I hope you guys can understand. I will continue with the next video for subchapter 1.3. Thank you.